Okay, so in this question we're being asked to find the rate of change of the area of a rectangle where the rectangle has a width of x and a length that's 4 times that, so we'll say 4x. So the first thing we should do in a question like this is, well, let's make a formula for the area of a rectangle. A rectangle has an area of its length times its width. In our rectangle, the width is x. We've been given that in the question. And then obviously, if the length is 4 times that, we can say that that's 4x rather than introducing a different variable like y. So the area is equal to 4x times x, and 4x times x is 4x squared. So we have a formula for the area of the rectangle. The formula for the rate of change of the area, well, that's differentiation. When you derive a function, so we have a function for area in terms of x, the width. If we derive that function in terms of x, we'll find the rate of change of the area in terms of x. So this is a quadratic function. We're going to use the power rule for differentiation. So the 2 is going to come down and multiply by the 4 to give us 8, and then the 2 reduces to give a power of 1. So the a dx is equal to 8x. Now to pause here just for a second, because it can be useful just to interpret what we found using real values. So they want us to find the rate of change of the area when the area of the rectangle is 225. But let's say we wanted to find the rate of change of the area when x was, we'll make up a value for x, let's say that it's 5. Well, when x is 5, the length 4x is going to be 4 times 5, so that's 20. We can clearly see that the area of this rectangle would be 100. So we could have found that using our formula. So area is equal to 4 times x squared, x being 5 in this example. 4 times 5 squared is 4 by 25, which is 100 centimeters squared. So this formula finds the area. Well, what does this formula find? Well, this formula finds the rate of change of the area. So if we find dA dx at that moment in time, when x, the width is 5, we'll have 8 times 5, which is 40 centimeters squared. Now, what do I mean by 40 centimeters squared? Well, at that exact moment in time when x is 5, the area is 100, but it's changing by 40 centimeters squared per centimeter change in the width. So that's what we find when we find the rate of change. Now, specific to this question, they want us to find the rate at which the area is changing when the x value equates to an area of 225. So what we need to do is we need to let our formula for the area, 4x squared, equal 225 to see what is the value of x that gives an area of 225. We saw a second ago, if you put in x equals to 5, we have an area of 100. So clearly the x value is bigger than 5. So if we let 4x squared equal 225, then to find x squared, we're going to divide both sides by 4. So x squared is 225 divided by 4. X is the square root of 225 over 4. The square root of 225 is 15. The square root of 4 is 2. So x is 15 over 2. And then we can say that x is 7.5. So when the area is 225 centimeters squared, x is equal to 7.5. And the length, 4 times x, is 4 7.5s, which is 30. 7.5 times 30 is 225. Well, how fast is the area changing at that point in time? Well, let's sub x into the rate of change of the area. So the dx is 8x. At x equals 7.5, that's 8 by 7.5, which is 60 centimeters squared per centimeter. So at that exact point in time, when x is equal to a width of 7.5, and the length is equal to 30, and the area is 225 centimeters squared, the area is increasing by 60 centimeters squared for every centimeter that x changes by.